Welcome back. For this lesson, we'll learn the fundamental law of active management. Let's get started. Fundamentally, an active manager makes forecasts of the active return of individual securities in the benchmark, which we denote as mu. In the end, the actual realized active return of each security may differ from the forecasts. This information coefficient measures the correlation between the realized active return and the forecasted ones. If the realized returns turn out exactly as forecasted, the correlation is 1. And conversely, if the realized returns turn out exactly the opposite of what was forecasted, the correlation is -1. The information coefficient can therefore be seen as a measure of the manager's skill in forecasting returns of securities. The Grinold rule allows us to compute the expected active return based on the information coefficient, active risk, and a standardized score assigned by the active investor. For example, let's say an equally weighted benchmark has just 4 securities whose active returns are assumed to be uncorrelated with each other and have active return volatilities of 25% and 50%. An active manager believes the first 2 securities will outperform the other 2 over the next year, and thus assigns scores of +1 and -1 to the first and second groups, respectively. Let's say the manager has an expected information correlation of 0.2. Based on Grinold rule, the expected active return for each security will be as such. Based on these forecasts, the manager will want to determine the optimal set of active weights to achieve the highest expected active return. In the last lesson, we mentioned that for an unconstrained portfolio, we can determine an optimal set of active weights for individual securities that maximizes the information ratio, given a particular level of active risk. And here comes another formula. Based on the Grinold rule, the optimal active weights can be calculated based on the expected active return and variance of the individual securities, the desired active return, the information coefficient, and BR, which refers to the breadth. The breadth is the number of independent active bets taken per year. For a simple single-factor portfolio based on just the expected return of individual securities, the breadth is simply the number of securities that have deviations in weight from the benchmark. In this case, breadth is 4. However, do note that the definition is the number of active bets per year, so if the manager does this monthly, the breadth should be 48. The active risk here is the investor's desired active risk. So let's say the investor wishes to limit risk to 9%, we apply the formula and we get the following optimal active weights for each security. The expected active return of each security can be calculated, and if we sum them up, we get the expected active return of the portfolio, which is 3.6%. Since information ratio is the active return over active risk, the information ratio for this optimal portfolio is therefore 0.4. Now, there is a much quicker way to calculate this, especially for portfolios with many securities, and that is to use the basic fundamental law. For an unconstrained portfolio, the optimal information ratio is the product of the information coefficient and the root of the breadth. And since the expected active risk is the information ratio times the active risk, we can express the expected active return as such. Let's verify if what we've calculated follows the basic fundamental law. The information coefficient is 0.2, the breadth is 4, so the information ratio is 0.4 as we have calculated. And based on the selected active risk of 9%, the expected return is therefore 3.6%. These are exactly the same as what we calculated earlier. Let's practice what we've learnt. The KG Ultimate Fund is an unconstrained fund that claims to have an ex-ante information ratio of 0.2 based on the fundamental law. Given that the fund makes active decisions on 25 securities in a year, and that all the active decisions are assumed independent, what is the information coefficient that the fund claims to possess? Pause the video now and work out your answer. And we're back. The basic fundamental law states that the IR is the IC times the square root of BR. So this is how we calculate the information coefficient. Assuming breadth is 25, the information coefficient should be 0.04. You should be very clear that the basic fundamental law only applies to unconstrained portfolios. That is, the manager has no constraints on the extent of deviation from benchmark, including taking short positions. In practice, many active managers have to work with certain constraints that limit the amount of deviation that they can take. In such cases, we have to refer to the expanded fundamental law, which takes into account the transfer coefficient. For our example, let's say the portfolio is constrained, so the managers applied the following weights instead of the unconstrained ones. Do note that these rates are still optimized. That is, they will produce the highest IR within the constraints given. we calculate the expected active return, which works out to 2%, and active risk, which if you calculate will work out to 9% as specified by the active risk limit. Based on the expanded fundamental law, we can work backwards to the transfer coefficient, which is 0.56. You could look at it this way. The maximum active return of the portfolio is 3.6% if it is unconstrained, so the weights can be optimal. However, if the portfolio is constrained, and based on this particular set of active weights, the expected return is 2.0%. The transfer coefficient of this particular constrained portfolio is 0.56, and the corresponding information ratio is 0.22. As such, we can see the transfer coefficient as a measure of how close the constrained active returns are to the optimal active returns, or the correlation between the actual and the optimal. The TC should be between -1 and 1, with 1 being the unconstrained portfolio. And let's pause for another practice. The fund managers of KG Ultimate Fund decided to create a variant of the fund called the KG Secure Fund. The fund is identical in every aspect of the Ultimate Fund, other than the added constraint of being long only. Because of the constraints, the managers expect the return to be 1.5%. Given the following table, fill in all the blanks. Pause the video now and work out your answer. And we're back. Well, let's fill in the easy parts first for the Ultimate Fund. The IR is active return over active risk. You should easily get 0.2. You'll get the same answer using the fundamental law as well. The transfer coefficient for an unconstrained portfolio is simply 1. Moving on to the secure fund, we are told it is identical in every aspect to the Ultimate Fund, other than the long-only constraint. We can expect the IC and breadth to be the same, as these are not subject to the constraints. The active risk is also the same, as it is a level selected by the managers. With active return and active risk, we can calculate the information ratio, which is 0.15. The expanded fundamental law states that the IR is the IC times root BR times the transfer coefficient. Working backwards, the transfer coefficient must be 0.75. Earlier, we've learned that information coefficient is a measure of manager skill, as it is the correlation between the manager's forecasted active returns of individual securities and their realized active return. This forecasted return is based on the assumption of an unconstrained portfolio. For portfolios that have constraints, the extent to which the expected active return can reach the unconstrained return is measured by the transfer coefficient. As such, the fundamental law makes sense, as the information ratio, which measures the risk-adjusted active return, is a function of the manager's skill, the number of active bets taken, and how close the portfolio is to the unconstrained portfolio. Thus far, we've discussed the fundamental laws in the context of ex-ante performance estimation. The fundamental laws can also apply in the evaluation of ex-post performance. Ex-post information coefficient can be calculated based on actual realized return, which we denote as ICR. The fundamental law can therefore be written as such. This is the expected value added given the realized skill of the manager for that period. We can explain any difference between the actual active return of the portfolio and the conditional expected active return with a noise term. And lastly, the transfer coefficient also comes into play when calculating the optimal amount of active risk for an actively managed portfolio with constraints. If you recall from the last lesson, this is how we determine the optimal active risk for an unconstrained portfolio based on the optimal information ratio and the benchmark's Sharpe ratio and standard deviation. And this is how we determine the Sharpe ratio of this optimal portfolio. For a constrained portfolio, the information ratio is no longer optimal, scaled down by the transfer coefficient. And that's how we calculate the optimal level of active risk for a constrained portfolio and the corresponding Sharpe ratio. Essentially, they are the same formulas as that of the unconstrained portfolio, just that the optimal IR is replaced with the scaled down IR. With that, let's revisit the example from the last lesson where we calculated the optimal active risk, its expected active return, and Sharpe ratio for portfolio P, which is a combination of the KG Secure Fund and the benchmark portfolio. Now, let's say a new portfolio Q is to be constructed by combining the KG Secure Fund and benchmark portfolio, which we've determined its transfer coefficient is 0.75. Determine the optimal active risk for portfolio Q, its expected active return, and Sharpe ratio at the optimal level of active risk. Pause the video now and work out your answer. And we're back. We've already calculated the IR of the ultimate fund, which is 0.2. Since the ultimate fund is unconstrained, this is actually the unconstrained optimal IR, which we denote as IR star. The IR of the secure fund, which has a transfer coefficient of 0.75, is therefore 0.15. And with the IR of the secure fund, we can calculate the optimal active risk, expected return, and Sharpe ratio using the same formulas, just making sure that the IR we use is the IR of the secure fund, which is 0.15. And that wraps up this lesson on the fundamental law of active management. Next, we'll touch on the applications and limitations of the fundamental law. See you again.